Okay, let's work on this example 3. Listen to the statement. It says that we have a box with a mass of 10 kg. It's at rest on a horizontal plane. So now we have a force that is applied at an angle of 30 degrees to the plane as shown in the figure below. If the friction of the force amounts to 1 Newton, calculate the acceleration. So now what I need you to understand in this problem is the direction of the applied force, the direction of the friction. We're going to discuss that. Most of the time it's also the best to do what we call a free body diagram. So in an exam they might ask you to do what? To draw a free body diagram. Let's start with the free body diagram so that we can indicate how many forces are acting on this diagram. Let's indicate how many forces are acting. So remember, if an object it is in contact with the surface, is going to experience what? It's going to experience the normal force. So it's going to experience the normal force, and the horizontal surface will experience what? The weight of that object. This is Fg. That is the vertical forces. But now remember, this is not the only vertical force that are acting on the object. If this, we have this as our Fx in that direction, this is my Fx, I'm going to have another force traveling this vertical force. Using tail-to-tail method, our Fy is moving up. So now what I'm trying to say is that we have another force here. We have another vertical force here. We have another vertical force that is moving in an upward direction. I'm going to call that one Fy. That's how you do for vertical forces. Now let's discuss about the horizontal forces. So if you use the components, if we use the components, we're going to include that Fx, which is moving to the right. So this will be my Fx. Okay, this will be my Fx, and I'm going to have the frictional force Fk moving in to the left. But now, if you decide not to use the vertical components, you can remove these two guys, your components, and include that applied force at an angle. So the applied force will look like this. It's up to you how you prefer to do your free body diagram. So now they said that we need to calculate the acceleration. So in order for you to calculate the acceleration, there's one thing I need you to focus on. Which is horizontal forces. I need you to indicate how many horizontal forces do we have. You see, we have the Fx moving in that direction. This is my Fx. Then what is another thing that we have is what? It's your Fk. So these are the only horizontal forces you have. So now what you're going to do, remember on our previous video we discussed that our Fx, it's equal to F. So it's F, the cos of theta. So if you don't understand where is this coming from, you can go back and refer to the previous video where we were talking about vertical and horizontal components. So now what you're going to do, we're going to use Newton's second law, which states that F net is equal to ma. F net means that we need to add all the forces that are acting on the object. The horizontal forces, in this case. So these are the only force that we need to solve acceleration. So another thing, the most important thing is to choose direction. It's very important that we choose direction. So now I'm going to take the direction of the motion as positive. So I'm going to choose right as positive. So all the forces that are going to the right will be positive, and all the forces that are going to the left will be negative. So this force will be positive, this force will be negative, because these two forces, they are moving in opposite direction. So from there, we can say that F net says that we need to take Fx, we need to add it with what? I'm going to put it inside the bracket, the Fk, because it will be negative, and equate this to what? To Ma. I just have to substitute. Remember fx, we said it will be f, the cos of what? F, the cos of that theta. Positive times negative will give us negative fk. And this is equal to ma. When you have it in this form, what you can do next, you can just do a quick substitution. We know what is our F. Remember this F, it's your applied force. They said this object, it is applied, they said 20 Newton force that is applied on that object. So I'm going to have 20 Newtons. The cos of that angle, the cos, the angle is given as 30 degrees. We minus what? We minus Fk. So now, Fk is the frictional force. Remember the frictional force, it's also given. There's no need for, when we explain this, there's no need for us to make it more complicated, tell you all. You see, we just have to focus what the question is asking. Né? So now, if I say 20 minus the cos of 30, I'm going to minus that 1. And this is equal to the mass is 10 and we're looking for A. We just have to solve this and isolate A. So I know that someone might prefer to find F net first, to calculate F net first and tell us what is the F net. Therefore, what they're going to do is that from the formula F net, it's equals to MA. They might make A subject of the formula by dividing by M, divided by M. Therefore, the acceleration will be F net over M. That's the other way to do it. So now what I'm going to do here to isolate A, what I'm going to do, you need to say that 20, the cos of 30 degrees minus 1, you need to punch that, everything inside the calculator. Né? So the answer that you get, I need you to divide it by 10. The answer that you get when you divide this guy, you need to divide it by 10 to get your acceleration. So we have 16,32 divided by 10, which will give us the acceleration. So now acceleration will be 1.632 meters per second squared. That's how you solve acceleration for this type of problems. That's how you solve acceleration. First thing first, make sure that you draw the correct free body diagram. So what we did here, let's do a quick recap. We resolved the applied force into what? The applied force into its vertical and horizontal force. But in this case, why are we doing this? Remember, it is acting at an angle. So what we need, or what you noticed, is that the force that handles the motion of the box is that horizontal component of the what? The horizontal component of the initial applied force of that 20 newtons. So when you understand this, when you understand how to draw the free body diagram, everything becomes more easy for you to work with. You just have to know, most of the time they'll give you where you have to first calculate the kinetic friction. We'll do more examples on those ones.